We are going to introduce complex numbers today. Complex numbers are when you have a negative inside of a radical, okay? Because we cannot have negatives inside of radicals currently, yes? Okay, so we're going to introduce something called the imaginary unit. Okay, not all quadratic equations have real number solutions. For example, x squared equals -1 has no real number solution because the square of any real number x is never a negative number. Correct? Okay, follow along, understand? So, with that being said, we get this imaginary unit, okay? To overcome this problem, don't you love how that's worded? Mathematicians create an expanded system of numbers using imaginary units. It is represented by the letter I, lowercase I, defined as I equals radical -1. So if you have radical -1, I can change it to I. If I have I can change it to radical -1. They can be interchangeable, okay? I squared, okay, equals -1. These are also interchangeable. I squared is -1. Okay? The imaginary unit I can be used to write the square root of any negative number. So now, any negative number that's inside of a square root, we can take out an I and take the square root then of whatever is left inside. So if I had -9, if I have the square root of -9, it would translate to plus or minus 3i. Because the square root of 9 is plus or minus 3, and the -1 is represented by the I. So now I can get some answers and some solutions, okay? If r is a positive real number, then radical -r equals I radical r. Radical -3 equals I radical 3, okay? By property 1, it follows that if parentheses I radical r squared, it would equal -r, because I would get I squared, I radical 3 squared would be I squared times 3, which equals -3, because I squared is -1. So I'm going to be able to get number solutions now. Okay? So now we're going to solve some equations. We're going to just practice. Let's say you have 2x squared plus 11 equals -37. How do you solve this? What do you want to do first?
Put 11 to the other side.
Good. Move 11 to the other side. If I move 11 to the other side, I get 2x squared equals -48. Yes? Now what? Divide by 2. Good. Divide by 2 and x squared equals -24. Yes? Now what?
Square root.
Square root it. So x is going to equal. What are the factor, or what does 24 break down into?
8 and 3.
8 and 3, and 8 breaks down into 4 and 2, right? And 2 and 2. So you have 2 and you have 6 left inside, yes? What do I have to do with that negative? I have to bring what out? An I. So I get plus or minus 2I radical 6. Okay? Plus or minus 2I radical 6. I still have a positive and a negative answer, but I have that imaginary number there now to represent the negative that's inside of the radical.
What makes it complex?
Okay? We solved everything else the same way, we just have to bring the I out. Anytime there's a negative, you have to bring an I out. Okay? This one, x squared equals -13. How do I solve that?
Square root.
Take square root. And is there a square root of -13? No, so it's just going to be x equals plus or minus I radical 13. Okay? Notice that the I is always coming in front on this when you're dealing with the radical. If you have something left over, the radical comes after it. Okay? Then we have x squared minus 8 equals -36. What do I do?
Add 8.
Add 8. Add 8, and I get x squared equals -24 again. Okay, so we should already know that one. It's over here. So x equals plus or minus 2I radical 6. Yes?
But it's not 20. Is it? No, I'm just checking.
No, it's not 24. It's 28. I'm crazy. It's 28, right?
I was checking.
No, you're right, I'm being crazy. So that's 2 and 14 and 2 and 7, right? So I have 2 plus or minus 2i radical 7, yes? Okay. So I have some, nice little things going on there. Now, let's look at this. Complex numbers, okay? A complex number can be written in standard form. The standard form is a plus bi, okay? Where a and b are real numbers, meaning this. If I have a complex number, okay, this right here, 2 plus 3i is a complex number. You have your constant, then you have your imaginary number, okay? A and b, a is this 2, b is that 3, and then the I comes with it. So when it is in standard form, when a complex number is in standard form, it's the real number plus the imaginary number or minus the imaginary number, okay? If b equals 0, then a plus bi is an imaginary number. If b does not equal 0. If a equals 0 and b does not equal 0, then a plus bi is a pure imaginary number because there would be nothing that's being added to it. It would just be like 3i or negative 6i. That's a pure imaginary number, okay? Two complex numbers, a plus bi and c plus di are equal if and only if a and c are equal and b and d are equal. For example, x plus yi equals 5 minus 3i. Then x would have to be 5 and y would have to be negative 3. Okay? Then you have the sum and difference of complex numbers. Okay? The sum of complex numbers says that you can have a plus bi in parentheses plus c plus di in parentheses, and it's the same as equaling a plus c and then b plus d, and you add the I to the end. So you're adding like terms, okay? It's the same as saying x plus 12 plus 2x plus 3. I get 3x, right? And I get 15, okay? When I'm adding imaginary numbers, if I have 6 minus 2i plus 7 minus 4i, okay? I do 6 and 7 together, which is 13, and then I have minus 6i, okay? Same concept, you're adding like terms, okay? That's the same with the difference, okay? Actually, I'm going to make this smaller so that we can see. Okay. Circuit components such as resistors, inductors, and capacitors are all oppose the flow of current, okay? This opposition is called resistance for resistors and reactance for inductors and capacitors. A circuit's total opposition to current flow is impedance. All these quantities are measured in, omegas, yeah. They just abbreviated that weird. Okay, component symbols. So the resistor has that like one, inductor has little swirlies, and capacitors are the ones that back up to each other. Resistance or reactance is RLC, and then you have RLICI, negative CI, okay? What do you think that I means? Yeah, that you're gonna have some type of imaginary scale going on, okay? So they use this in science. The table shows the relationship between a component's resistance or reactance and its contribution to impedance. A series circuit is also shown with the resistance or reactance of each component labeled. The impedance for a series circuit is the sum of the impedances for the individual components. Find the impedance of the circuit shown above. So all they want us to do is find the impedance of the circuit shown above. How can I figure that out? Okay, look at the diagram they gave us, because they give us all the numbers that we need, okay? If it's a, let's start at the left here with the 3 omega, okay? 3 omega, what symbol is with that 3 omega? Inductor. An inductor is represented in impedance with what? Li. So what is it going to look like then when we're doing inductors? What's the unit measure right now? 3 what?
3
Sort of. You can knock some stuff out of there.
3
How about the 3 replaces the, no, can I replace imaginary numbers? The L, so that inductor, okay, is represented by 3I. Up top you have 5 omega, which is a resistor. Resistor is represented with just what? So what is that gonna be, plus 5, good. And then you're gonna add to it the capacitor, which is what? Negative, yeah, negative 4I. So I have 3I plus 5 plus negative 4I. What do I do to simplify that? Combine like terms. So the 5 stays, right? What's 3I minus 4I? So this is the impedance of the circuit shown there.
There's not gonna be a question like that.
There could be. It's really not that hard.
Yeah, but like, all the symbols, like, they just like.
Okay. Now, let's do this in standard form. This, once again, listen, this is very simple, okay? Don't let the i's confuse you. It's the same as multiplying an x times an x. What do you do when you multiply x times x? You get x squared. If I have an I squared, what does it turn into? What does I squared always become? Negative 1. So remember that, because on some of these, if I get an I squared, I'm gonna get a whole number answer, because I'm gonna turn it into negative 1 and keep going. Okay, so let's look at this first one. You have 4I, and then you have parentheses, negative 6 plus I. What do you think I need to do with this 4I? Distribute. What's 4I times negative 6? Negative 24I, good. Negative 24I. What's 4I times I? 4I squared. Now, what, this is just stays negative 24I. What does this become? What does I squared become over here? Negative 1, right? So I get 4 times negative 1. What's 4 times negative 1? And so when I write this, I have to write it as negative 4 minus 24I. You have to write it in standard form, which means your whole number comes before your imaginary number. Whole number, then imaginary. Whole number, then imaginary. Okay? So when it says write the expression as a complex number in standard form, that's what they want. Negative 4 minus 24I. Okay? Negative 4 minus 24I. Now, take a look at this next one. Let's do 9 minus 2I times negative 4 plus 7I. What do I have to do here? FOIL. What's 9 times negative 4? Negative 36. What's 9 times 7I? 63I. What is negative 2I times negative 4? 8I. And what is negative 2I times 7I? Negative 14I squared. Good. Now, combine like terms and we're going to change some stuff. Negative 36 stays here. 63I and 8I gives me what? 71. And then what happens here? It changes to negative 1, and negative 1 and negative 14 gives me positive 14. Now, what's negative 36 and positive 14 together?
22.
Yep, plus 71I. That's now in standard form. Yes, Mark?
Why wouldn't it be 71 I squared?
Because you're not multiplying them together, you're adding them together.
So when you add it, don't.
You don't square it, correct. When you add, you just leave it. Okay. So, bummer. This is the bummer part. Remember how you can't have radicals in the denominator spot? You also can't have imaginary numbers in the denominator spot, okay? That is a no-no. So, it is called a complex conjugate when you see that. And when they want it written in standard form, that means they want the imaginary numbers out of the bottom, okay? So, yesterday we did this with radicals. There's no new rules to this, it's the same rules. So what do you think I have to do to get that 1 minus 4i out of the bottom.
Multiply that in,
Yeah, and multiply it by 1 plus 4i. Good. Multiply it by 1 plus 4i. Now, that means I've got a lot of foiling to do, yes? So let's just focus on the top. What's 7 times 1? What's 7 times 4i?
28.
28i. What is 5i times 1? And what is 5i times 4i? 20i squared. Great, now let's go to the bottom. We'll simplify that later. What's 1 times 1? Now, what do you think I can do on this also?
Just cancel it.
Yeah, just skip the middle part, so I'm just gonna go straight to the end. What's negative 4i times positive 4i? Negative 16i squared. Now, let's combine like terms. Up top, I have 7, and what does this become? Negative 1, which makes this then
Negative 20.
negative 20. So I'm gonna just, so what is 7 minus 20? Negative 13. And what's 28i and 5i added together?
33.
Yes, 33i. Now on bottom, what does this become? Positive 16, so what's 1 plus 16? So you can leave your answer like this, or, remember yesterday we talked about this, in your book they might break it down in case they need to reduce. So you can see it written either way. Negative 13 plus 33i over 17, or negative 13 17ths plus 33i over 17. That's how you write it in standard form. So it's nothing new compared to yesterday. We're just using imaginary numbers. And listen, here's how you know if you did it wrong. The bottom will always have a whole number. There will be no i's left in there. Which means if there's i's left, that means you didn't change the I squared to negative 1 most likely. Okay, that's the biggest mistake. Oops, I didn't delete this one. Oh well, let's look at it, okay? Absolute value. Absolute value does what to a number? It makes it positive because it's a distance, right? It's a distance from a certain point to another point. So the absolute value of complex numbers, okay? Here's the deal. Do you see this right here? This axis. What is this axis labeled right now? Imaginary. So when we are graphing, we can graph imaginary numbers, okay? If I want to graph 5 minus I, okay, this is my x, and this is my imaginary axis, okay? Your imaginary axis takes place of your y-axis. So the x-axis still stays. This becomes my imaginary axis instead of y. So if I want to graph 5 minus I, I'm going over 5, 1, 2, 3, 4, 5, and I'm going down 1. That's 5 minus I. Okay, you're just pretending that it's your y. Does that make sense? Okay, it's not super difficult. So when you're finding the absolute value of something, okay, you have to do a squared plus the square root of a squared plus b squared. Okay, so Pythagorean theorem, plus c squared equals a squared plus b squared. So a squared plus b squared, you're taking the square root of it, okay, to find a distance between things. That's what you're working on tonight. And then on Thursday, when you get back to me, we will review all 3 of these sections before you take your quiz on Friday.